Hi. So someone asked if this can take a 15 to 20 mile per hour gust. The answer is no. This is a light gust hitting the aircraft. So yeah, in the current configuration, this is a zero wind aircraft. And this is how much the wind is causing the trees to whisper around. Anywho, this is a test program, so I try to take every opportunity that that just pops up to make new tests. So this is a great situation to try to fly the craft with two motors. Yep. And this motor is just for counterbalance at this stage. I would have liked to have the broken motor's propeller to windmill. I think that's a more realistic fail scenario, but nevertheless it would be interesting to see how it acts with only two motors. And it's slightly off balance. I tried to mount the motor like at the same distance from the wingtip there, but you can see it wobbles a little bit. But it's totally controllable. You really lack power, so it's difficult to stop a descent. But still, you have control authority over the craft. That's good news. Okay, now I'm trying to address the dissymmetry of lift problem, and I choose to start with adding weight. That will cause the rotor to spin faster before it takes off, so I have a little more margin for retreating blade stall. So this might give me a little bit higher lateral maximum speed. So I start with the 3 kilograms of weight, but as it turns out, that only causes the rotor to go from 0.9 revolutions per second in its original state to somewhere around 1 revolution per second. So it's kind of not that much difference in the tip speed. So it's around 1.5 meters per second higher tip speed that you could use at least partly to go faster forward. So that's partly because you are a little bit higher of you have a higher stall speed of the retreating blade, but also the control surfaces has a higher airspeed, so we have a higher control force via the control surfaces. Okay, so now I'm upping the game here to 6 kilogram of weight, and that's 50% of the aircraft's original takeoff weight of 12 kilograms. So it's a significant increase. But it turns out that this is too much. You can take off, you can start to fly, but you have too little overhead power, especially when you are in a descent. It's a descent. It's very hard to break the descending motion, the momentum. So I didn't immediately catch this, so I started to fly off here. And this 6 kilos causes a tip speed to go from the original 0.9 to 1.12 approximately. Okay, so here I feel that I don't really have the vertical control over it, so I'm flying it back. And I accidentally get it to have a little bit too high vertical momentum, so I land in the slope first, and then I manage to take it up again and land it on the gravel surface there. And you can see that it has a higher rotational speed. And then I'm trying to get it somewhere in between value here, so I'm going for a 4 kilogram of flying weight extra. And that works better. But all in all, I really don't think that I gain much a maximum speed or like a feeling of better control in the air. So I'm going to try out another alternative method of having a higher tip speed. But first here you can see the 4 kilogram flight. I did several hops with each weight except the 6 kilogram weight, but that would just be too much to document or show everything here in this clip here. Yeah, and just for reference, now I've taken away all the weight, so now I'm down to the 12 kilo original takeoff weight of the vehicle. And I must say that I do prefer the lower wing loading, at least as the in this setup where the power system is sort of matched to be this to have this 12 kilogram of takeoff weight. So I would probably get a much more better penetration and much better flight feeling if I have a higher wing loading with the accompanying power system as well, so that the motors are more powerful and propellers have higher pitch, so that it can handle the higher tip speed. So yeah, this is much more comfortable, although again it's more wind sensitive in this state. I think I mentioned earlier that it's not really flying around that's the tricky part. It's actually very simple if it's a calm evening. However, descending from a height is difficult, since the rotor easily stalls when the air is coming more from underneath, which it does when you're moving vertically downwards. But it's a pretty picture right there, just hovering. So let's check out the descending phase. First slow, and then it accelerates once the wing starts to stall. So that's unpleasant, and something that I want to address later on. Otherwise it feels very controllable, but this descending is a bad thing. And of course the gust sensitivity, but it's sort of the way the craft is right now with the low wing loading. It's just a matter of physics. But I would like to make adjustments to make the descending better. But it's so nice just to fly it, so it's okay that I can't solve the problem that I'm addressing at the moment directly. It's just a joy to fly it anyway. Yeah, so these hoverings are good to get a RPM measurement, so you can just time the rotational there with the stopwatch and see what RPM you are at the different configuration with a different weight. Okay, so let's move on here to the next test. Oh yeah, just wanted to show you the disassembly of the craft. So I'm getting out of light now, so I have to round up this flight session. Okay, so new day, new test. So I'm going from a angle of attack out at the tip there from 12.5 to 9.5 degrees. again, in order to, with the same 12 kilogram takeoff weight, have a higher rotational speed. Yeah, I have to adjust the settings of the digital swash plate there so that I get the servo action earlier. So I'm just like the timing is set earlier. So by going down from 12.5 to 9.5, I get a tip velocity increase to 1.1 revolutions per second, which corresponds to adding 6 kilograms of weight in the original 12.5 degree setup. But I had the agility of the 12 kilogram original takeoff weight instead of 18 kilos. So this will be interesting, of course. So just by flying it around for a couple of seconds, it becomes obvious that this is a better setup for this aircraft. It has better penetration. It's easier to fly, and you feel that it's more controlled. So that's really nice. I'm not sure what happens with the efficiency when I lower the angle of attack. I haven't made the corresponding change to the pitch of the propellers, of course, because they're 12 by 12 fixed pitch propellers, and the lower the angle of attack of the rotor is, the propellers sort of run out of pitch, but still it feels very nice and controllable. So I think many, or a couple of persons, at least quite many, haven't seen the first film in this series, so they ask about the center part there, how it comes that it's stationary when the wing spins. So I'm just giving you zoom in here. So we can see the yaw motor there with a yellow, what do you call it, gear there, keeping the center part in the stable. Once I turn off the flight controller, it starts to drift with the wing. Yeah, there. I turn the flight controller off and it starts to drift with the wing. And the portion there is fastened to the center shaft, so its center shaft is also stationary. And here I'm just doing a power test, so I checked where I had the throttle stick and took a static measurement there, so I seem to be flying at around 740 watts, which corresponds to a 16.6 gram thrust or lift per gram of per watt of power, so 16.6 grams per watt. Okay, so now I'm adding a GoPro camera here for you to enjoy. I just wanted to see the bird's view there, and also you can see the wings passing by. It's sort of funny. Yeah, so this clip doesn't really give you much knowledge, but it's just interesting to see how it would come out, adding a GoPro on the top there. Yeah, wouldn't that be a sight to see in real life, sitting in the machine? Of course, that machine would be bigger and the propeller would turn even slower. It would be super amazing. Okay, so now I'm working with the yaw motor there, so I'm turning this center portion of the machine around, independent from the wings turning. And this is the actual flight where the GoPro sits on top there. So now I have taken a rudimentary measurement of how much power it consumes. I actually tried to film the amp meter in flight, but the GoPro actually just slid off, so it couldn't capture the actual flight power consumption, but it's around 740 watt. I just wanted to see what kind of difference it would make if I remove the leading edge ribs. So many people have said that this doesn't have any airfoil, but actually it did have kind of an airfoil. But now I'm taking them away and I'm like retaping the upper surface. So now it's actually just tape that is shrunk between with the aluminum tubing in between. So it's two surfaces still, but it's totally flat except for the rounded leading and trailing edge. Still 9.5 degrees of pitch out there. So let's see if it even flies. I really sort of expected that I might crash it this time because I'm doing some pretty radical changes to it, but as it turns out, it flies just fine. There are negative characteristics coming with the lack of a proper airfoil. And I'll get to that in just a moment. But the hover efficiency is only slightly worse. It's not much. It's really not much. I don't have a number on it, but I know where I have my throttle stick. And before I was just under one of the marks there on my throttle stick, and now I'm slightly over, but it can not be more than 1 or 2 amps more power to hover this. So yeah. Because I'm also trying to optimize this machine, of course, for simplicity of build. So if I can do away with the leading edge spars, that would be great. But as it turns out, it's still very nice to fly laterally, forward, backwards, sideways. However, the vertical descent becomes even more difficult, and that is absolutely what you could expect when you're taking away the leading edge ribs, because they were there to guide the airflow on top of the wing, and when you remove that, it's even easier to stall the airfoil. And again, when you're descending, it's easy to accidentally stall it by going down too fast. The remedy is just to add power, and then you increase the rotational speed, which turns the airflow from the perspective of the airfoil. It seems to come more from the forward point of view again, rather than from the underside of the wing. So you can always, at least if you haven't have accelerated too much vertically, you can still arrest the fall by just adding power, like here, like I just did in this clip. And I will show you another point of view when I'm trying to do a descent with this zero airfoil iteration of this machine. Okay, so now I'm high up there, and I'm just trying to descend and to see how much it will start to oscillate or stall or whatever it will do. And as usual, it starts nicely and then it accelerates and gets so wobbly, and the wings are apparently in stalling conditions from time to time. It's easier if you fly sideways and go down. That's better for the machine, but I want to be able to just go straight down, of course. It's super important. If you get stuck in updraft, you have to be able to descend quickly through the air. Okay, so that was sketchy. And let's see what the airflow does. So I'm tufting the wing, but before we check that, let's check out the tufting of the wing before I remove the leading edge spars, ribs. So here they are, the original setup. And we can see if we can detect any difference. So you can see the tufting there is really beginning at the very steep end of the wing, and I also have a little bit of tufting on the control surface there. And it's a curious, interesting pattern that develops after a while here. It's hard to say what's leading or lagging, but it would appear that the airflow attaches to the wing when the control surface is pointing downwards. Like when the system wants to generate more lift, it actually attaches the flow to the wing, and when it's pointing upwards, it's sort of getting more turbulent even far away from the control surface. Here you can see that motion of the turbulence and attachment of the flow, so that's funny, or curious. And here it's without the leading edge ribs, so the super simple airfoil. And it is absolutely more turbulent on the inner part there. It's worse than when I had the leading edge ribs, but further out it's well, somewhat attached. Well, especially at the part furthest out there where we have the control surfaces. Somewhat similar pattern here, you can see from the tufting that it's a lot of flow along the wing, but also pulsating with the movement of the control surface. And I will do another tufting test later on here, you will see, but let's move on here. Okay, so the moment you have all been waiting for, I think, I'm going to remove the inner part of the covering to reduce resistance, hopefully. So yeah, I'm cutting away the inner third of the inner quarter of the covering material there. So let's see how that impacts the flight characteristics. Again, sort of expecting that, you know, might not take off, might crash. So the RPM increases slightly, but it's not much at all, with 25% of the covering removed. And it has a very marginal impact on efficiency. It is not really. I did feel it, but it's. I mean, I have control over where I have my hovering position on the stick, but it's within a single click on the stick, and it's a very fine-tuned, fine course. It's fine. What do you call it? You have very many clicks from 0 to full throttle, and so it's really within the margin of error, and you know the battery is going down in voltage during the flight test. So it doesn't do really anything for efficiency, taking away that material. However, something totally unexpected surfaced here, and that is that I suddenly had a lot more stability when descending vertically, and I also have it's easier to move it laterally, so it flies better. I mean, it was a significant feeling of better control, better response, more locked in feeling, and a cleaner descent. So this is a huge thing, really. I was so surprised about that. I did expect efficiency to go up slightly, but I did not expect the general flight characteristics to be, influenced really at all. So this was a huge win that I did not expect. So it comes down so straight, but it takes a lot more effort to arrest the downward motion. So I have lost lift as well, but that was probably pretty power consuming lift, so it's not that bad, but it's significantly, noticeably more difficult to arrest the fall or the downward momentum. But I'm so puzzled by this, so this became one of the longest test flight sessions of on this day. So I just wanted to keep flying it to like really establish that what I'm feeling in the sticks is actually happening. So that's great news. I mean, it's not. You cannot just whip it up and down vertically. It still has the tendency to oscillate or like partially stall if you descend quickly. But I can descend a lot more quickly and without having the oscillation, and it's really super steady compared to how very sensitive it was for vertical motion earlier. So yeah. So now I feel very motivated to rebuild the wings with the leading edge ribs and also have this inner part of the wing open and see if these two can work together, these two changes, and give me the straight descent that I'm looking for, since the leading edge ribs also has an impact on how good it descends. Okay, so just showing the camera the vehicle in flight here. And I am up to 1.15 revolutions per second or so, which again is pretty close to the revolution per second it has with a 6 kilo of load in the original 12.5 degrees angle of attack setting. Okay, so I'm just like so I know, so happy, and it's just a joy to fly, so I just keep flying this, and I wanted to show you this this whole episode. I'm just doing it again, just going up and letting it drop down to verify that it still is not a freak accident that it came down straight. It keeps on coming down pretty straight, so super. And after this flight clip here, I am again attaching the GoPro on the tufted wing to see what the airflow does differently. The thing is, I sort of like the inner covering of the wing. It gives it sort of a endless wing situation. So I was hoping to. I was thinking that I would not have like wingtip vortices if the wing continues all the way into the center, obviously. So I thought that I might lose efficiency by cutting away the fabric in there, that I would get a lot of wingtip vortices on the inside of the wing, but it doesn't seem to be that way. So that's a positive surprise. Since the wingtip has such a high angle of attack in there, I was just assuming that I would have nasty vortices that would rob me from a lot of lift. But now with the I'm just standing here and just thinking, how did this even work? Why did it work so well? So this is me when I'm super excited and happy. It doesn't seem that way, but my brain is like, going on high revs. Okay, so yeah, I'm attaching the GoPro camera here to just see what's going on. Will you stop talking? Okay, here we are. So it's a big hole in the wing, but you can see the tufting further out there. And it's still sort of, yeah, it's a little bit of flow, I think, outwards, but the tufting there is really much more attached than before, I think. So, and it also still corresponds to what the rudder is doing, and of course, I mean the general wind over the wing, but it seems pretty good. Okay, so here's a new descent just from the significant height here to see what happens. It doesn't start to accelerate as quickly downwards as the previous setup. The previous setup were like gentle. When you reduce power, it started to descend gently, and then suddenly a larger portion of the wing stalled, so it just started falling. But this showed a more gradual descent, which is good. It's more predictable. Of course, you can reduce throttle even more, and you will be able to stall the wing and have a lot of problem, but you don't accidentally get into that region, which is very good. So it's yeah, it's just more predictable what it's going to do. So yeah, I'm just trying this again and again, and you know, if you try it one time, it's not really. I'm not doing things very scientifically, but doing it once would be super unscientifically. So I'm trying to like just establish where the design is at the moment, and I have a trouble stopping it. So I can, on one of the descents here, I hear how the propellers are cutting the grass. So I was so close to plant it in the ground there. Yeah, just showing off. Yeah, and even there where it actually picked up some vertical speed, it didn't start oscillate as badly as it did before. It was easy to just add power and get it stabilized again. But to arrest the descent, it takes a longer time with a slow angle of attack, and the at this stage rather unmatched pitch on the propulsion propellers. Okay, so there we are, and I'm sort of down now in the voltage, so I'm really thinking that I should like stop the testing for today and think about what to do next. And yeah, but I have like, what is it, 3.75. Okay, so I could make a small jump further. So I did cut away a little bit more fabric. Of course, that's the next step, or tape rather. So now it's the inner third of the wing is without covering. And just to like conclude that, I had too short time to verify this. The batteries was so low, so I can only do a couple of jumps, and it didn't seem better. It didn't seem worse. It was pretty similar, but I would like to fly it faster laterally, just to see if I gain some speed or agility, or like good flight characteristics out of this. But I think that the previous 1/4 cut was probably as good or better. But I'm not sure about that yet. I had to fly it a little bit longer in this setup. So that's coming up next for next time. And after that, I would like to add the leading edge ribs again to see if I can combine the good efficiency and characteristics of those with the inner surface removed. So okay, this was a long video, And I admit I sort of also use YouTube as a like cloud service for like remembering and keeping accurate what do you call it, like information for my own benefit on YouTube, but I hope that you can enjoy and learn something from that as well. So looking forward to the next video, and have a good day. Bye.